Hello students, welcome back. I am teaching you a course on circuits and systems, and in the today's class we will find out the value of the coefficients A0, AN and BN. So the objective is to find the or to calculate the coefficients which are A0, AN and BN. Well, fine. We know that a function f of t can be represented as equal to a0 plus summation of I is equal to 1 to n of an into cos of n omega t plus bn into sine of n omega t. Now, to find out the value of these coefficients a0, an and bn, let's start first the calculation of the value a0. So how to find out the value of the a0? We can integrating this whole function. So we can write integrating f of t with respect to t, that is dt, with respect to t. So let's find out and write it as integration from 0 to t over the whole cycle of f of t into dt. That will be nothing but the integration of this right hand side, which is nothing but a0 being a constant. So 0 to t of a0 into dt plus, let's assume that this part, the summation of the sines and the cosines, let's assume that this is equal to, say, some function which is f1 of t plus integration from 0 to t of some function. Let's assume that this part is equal to f1t into dt. So what is this f1 of t? So here let's assume that f1 of t is this part, that is summation of I is equal to 1 to n of an into cos of n omega t plus bn into sine of n omega t. So for this, then this can be written as a0 is a constant, so I can write this as equal to a0 integration of 1 dot dt will be equal to t, and when you put the limits from 0 to t, that will be equal to t itself. Plus, we know from the previous lecture, using the standard functions, the integration of f1, that is this part, will be equal to 0. So this is equal to 0 to t of ft into dt. So from here I can find out a0 by transferring this value to that other side. So therefore I get the value of a0 as equal to 1 by t integral from 0 to t of ft into dt. So this is the way you will be finding the value of the a0. Given any function, you can integrate that given function over the limit 0 to t, that is for one period, cross 1 by t will give you the value of a0. Now let's find out the value of the an. To find out the value of an, we will multiply the function by the cos m omega t. So therefore we can write down multiplying f of t with the cos of m omega t. So therefore the above function becomes the integral from 0 to t of f of t into cos of m omega t will be equal to this function multiplied by cos and taking the integral of it, this function multiplied by cos and taking the integral of that. So therefore this will become as equal to integration from 0 to t of a0 cos of m omega t plus integration of cos of m omega t over the limit 0 to t dot the complete function. This is summation of I is equal to 1 to n of an cos n omega t plus the integral, when you break this, will be from 0 to t of cos of m omega t dot summation of I is equal to 1 to n of the sine of n omega t. So now, using the relations discussed earlier, so we know what the integration of this function is and what the integration over the whole cycle this function is. So therefore this can be, we know that this will be equal to 0, this will be equal to 0, and this part is also equal to 0. Integration over the whole cycle for the periodic waveform is equal to 0. So therefore, what do you conclude? Therefore, what do you conclude? That this particular function, when you integrate after multiplying cos of m omega t, will give you the answer equal to 0 for n not equal to m. So this is for m not equal to n. But for so but for n is equal to m, when you put the value of n is equal to m, so this n and m, so therefore the above equation will become as the integration from 0 to t of a n cos of m omega t dot cos of n omega t dt. And when this n is equal to m, this will become cos square. So this will be equal to 0 to t of a n into cos square n omega t dt. And we know what cos square omega t is equal to, putting that cos square is equal to 1 plus cos 2 omega t by 2. So that particular value. So therefore this answer will be equal to t by 2, t by 2 dot an. So from this we can now find out the value of the an. So therefore we can write the an is equal to, we can take the other side. So this will become as 2 by t, and the integration from 0 to t of f of t into cos of m omega t. So this is the second relationship. So this is my first formula, and this is my second relationship, using which you will be able to find out the value of the an. Now, how do you calculate the value of the bn? So similarly, so let me just make some space here. So let me use this particular space. So now similarly, you can find out the value of the bn, and for calculating the value of, to calculate the value of bn, we can multiply the function both the sides by sine of m omega t and taking the integral. So multiplying by sine of m omega t and integrating. So what do you get in that case? Integral from 0 to t of f of t into sine of m omega t dt will be equal to the integral of the right hand side, that is 0 to t of a0 into sine of m omega t plus integral from 0 to t of the summation of I is equal to 1 to n of an cos of n omega t plus bn sine of n omega t, and this way and dt. So again, what do we know for n not equal to, for m not equal to n? So this right hand side will become equal to 0. So this part, so the RHS will be equal to 0. But for the condition m is equal to n, when you put the value of n and m, so this will become a sine square. So what do you, for this one, when, let me make some more space available. So for the condition that when m is equal to n, for m is equal to 1, n, putting this value, for m is equal to, putting the m is equal to n. So of course you have to have a sine function here. I've missed it. So you can write down here a dot sine of m omega t into dt. So when you put m is equal to n, so this term will be equal to, will be, and I also, yes, fine, that's okay. So therefore, I will get the integration from 0 to t of f of t dot sine of when m is equal to n. So I can write n omega t dt. So this will be equal to t by 2 times of b of n. This term will get cancelled and you'll get sine dot sine square. So you'll get this term multiplied by this, that is bn into sine square of n omega t, and you know sine square, the integration of sine square will be equal to t by 2, and bn is a constant or the coefficient. So therefore you can find out bn is equal to, taking it the other side, so this will become 2 by t integral from 0 to t of f of t into sine of n omega t dt. So well, fine. You now have the three formulas available to you. And let me write down all these three formulas again in this particular space. So let me write these formulas again here. So you get the value of an is here, and the value of bn, let me write it here. Therefore, the value of bn is equal to 2 by t integral from 0 to t of f of t into sine of n omega t dt. So, well, I will be extensively using these three relationships, one for a0, second is for the an, and third is for the bn. So where we found that a0 was equal to 1 by t integral from 0 to t of the function, given function ft into dt. So these three relationships are most useful while calculating the value of the a0, an, and the bn. So we'll see their applications in the next slide. Thank you for watching.